I'm going to go ahead and go over the study guide that your next test is on, exponential and logarithmic functions. So if you could, fast forward to any problem that you want. Sorry for squeaking or growling in the background. My dog is choosing to be crazy while I record this. But you can fast forward to any question you need help with. If you want to watch the whole thing, go for it, watch the whole thing, whatever you want to do. So I'm just going to go through the entire study guide, and then you can choose what you need to go over. So I'm going to go over the first 6. It's graphing the following functions. So number 1 is an exponential function. So I see that I'm going to the right 2 and I'm going up 1. So I'm going to go to the right 2, up 1, and I'm going to put a little plus sign there because that's my new origin. I now know with exponential functions I have horizontal asymptotes. So now when I want to graph this, again, I'm going to change my new origin to a different color. If you need to, you're just going to make a table. And you're going to pick any x values, so -2, -1, 0, 1, and 2. And then you only look at this piece. F of x equals 3 to the x. When you plug in 0, you get 3 to the 0, which is 1. When you plug in 1 for x, you get 3 to the first power, which is 3. When you plug in 2, you get 3 to the second power, which is 9. If I plug in -1 for x and I do 3 to the negative first power, that's 1 over 3. And if I plug in -2 for x, I get 3 to the negative second power, which is 1 over 9. So now I'm going to go ahead and I'm going to graph plot each of these ordered pairs. And I'm going to pretend that where my blue plus sign is my origin. So at that blue plus sign, that's my 0, 0, so I'm going to go over 0, up 1, plot a point. Now from that blue plus sign, I'm going to go over 1, up 3, plot a point. And then I'm going to go to the left one, so -1, up a third. As long as you have 3 points, you're good to go. And then I'm going to connect my dots. So now if I go through and I do domain and range and increasing, decreasing, domain is all real numbers, so -infinity to +infinity. Range is 1 to infinity. It's increasing from -infinity to +infinity. Since it's increasing, that means it's not decreasing. So now I have to determine end behavior. When x is going to -infinity, y is approaching 1. Because as x is going to -infinity, your y values are never getting past 1. So it's only approaching 1. As x is going to +infinity, y is also going to +infinity. As x is getting bigger, my y values keep going up and up and up and up and up and up and up. So that's my end behavior. So I'm just going to go down instead of side to side. So now let's go to number 3. So number 3, I'm going to the left 2 and down 3. So to the left 2 and down 3, I'm now going to make my new origin. And now I'm going to draw my horizontal asymptote. So now I'm going to make my table. So I'm only looking at 1/4 of x. 1/4 to the x power. So when I plug in 1/4 to the 0 power, I get 1. When I plug in 1/4 to the first power, I get 1/4. And when I plug in 2, I get 1/4 to the second power, which is 1/16. If I plug in -1, 1/4 to the negative first power is 4. And 1/4 to the negative second power is 16. So now I have to deal with this 2. This 2 is a vertical stretch, which means all of these y values are being multiplied by 2. So if you want to multiply all those y values by 2, you get 32, 8, 2. Multiply 1/4 by 2, I get 1/2, and then I get 1/8. So now I treat these as my ordered pairs. So if I go ahead and I graph 0 over 0 up 2 at my makeshift origin, there's my first point. And then I go over 1 up a half. That's my next point. And then I'm just going to go to the left one and up 8. 1, 2, 3, 4, 5, 6, 7, 8. That's right here. And then I'm just going to connect my graph. the best that I can to make an exponential function. So now, if I go ahead and do domain is again all real numbers, negative infinity to positive infinity. My range is -3 to infinity. This is increasing from negative infinity to infinity. And it's decreasing, it's not decreasing. My dog is literally running around my entire house. All right, so end behavior. As x is going to negative infinity, where's y going? When x is going to negative infinity, my y value is going up and up and up and up. It's going to positive infinity. I hope you can hear his feet running across the floor. As x is going to positive infinity, y is going where? So when x is going to positive infinity, y is going closer and closer and closer to this asymptote, which is -3. So now let's go ahead and let's look at number 5. Number 5, so this is telling me I'm not shifting left to right, but I am going up 4. So up 4, here's my makeshift origin. So now I'm going to make my asymptotes. So now I'm going to go ahead and I'm going to make my table. Some of you might not need to make your table, and that's awesome, but if you do, just want to make sure, that's fine too. So now I'm only looking at 2 to the x power to a value to fill out my table. So 2 to the -2nd power is 1 over 4. 2 to the -1st power is 1 over 2. 2 to the 0 power is 1. 2 to the 1st power is 2. 2 to the 2nd power is 4. So now this 2 tells me it's going to be another vertical stretch. So if I want to go through and multiply all of those y values by 2, I get 1/2, 1, 2, 4, 8. So now these are my ordered pairs that I'm going to plot. However, this negative tells me I have to flip it over the x-axis. So I should plot over 0 up 2, but I'm going to go over 0 down 2. And then I should go over 1 up 4, but I'm going to go over 1 down 4. And then always to get my left point, my 3 points, I go to the right and then I go to the left. So I'm going to go left 1, and then I should go up 1, but instead I'm going to go down 1. And I have my 3 points. So I'm now going to make my exponential function. So my domains is still all real numbers. It's always all real numbers for exponential functions. My range is -infinity to 4. It's increasing, it's not increasing, which means it's now decreasing from -infinity to positive infinity. So now we have to determine end behavior. So x is going to -infinity, where is y going? So when x goes to -infinity, y is going to 4. And when x is going to positive infinity, y is going to -infinity. Because as x is getting bigger, my y values are getting smaller and smaller. So now let's go back up to number 2. So I'm going left 3 up 2. Left 3 up 2. Here's my makeshift new origin. I'm going to draw my horizontal asymptote. Make my table if I need it. And now I'm only looking at 1/2 to the x power. So when I plug in 0, 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. 1/2 to the second power is 1/4. 1/2 to the negative first power is 2. And 1/2 to the negative second power is 4. So now this 4 tells me it's a vertical stretch by 4. So I'm going to multiply all my y values by 4. So 16, 8, 4. 1/2 of 4 is 2, and then I have 1. That 4 looks terrible. So now I'm going to go ahead and graph. So up over 0, up 4. Over 1, up 2. Left 1, up 8. I can't do. So what if I go over 2, up 1? So now if I do the domain is negative infinity to positive infinity. The range is 2 to infinity. It's increasing from negative infinity to infinity. It's not decreasing. So now let's talk about end behavior. X is going to negative infinity. What's happening to y? Well, it's going to positive infinity. And when x is going to positive infinity, where's y going? It's approaching 2. So now if I go on and look at number 4 is a logarithmic function. So still doing it almost the exact same way. Left 2, down 3. So left 2, down 3. Here's my makeshift origin. But now instead of a horizontal asymptote, I have a vertical asymptote. And I'm going to make my table. And instead of picking values for x, I'm picking values for y. So negative 2, negative 1, 0, 1, and 2. My base is 3. So this is like saying x equals 3 to the y power. So now, when I plug in 0 for y, x is 1. When I plug in 1 for y, x is 3. When I plug in 2 for y, x is 9. When I plug in negative 1/3, negative 1, I get 1/3. And when I plug in negative 2, I get 1/9. This 4 tells me it's a vertical stretch by 4. So I'm going to multiply all of my y values by 4. So negative 8, negative 4, 0, 4, 8. So now I'm going to plot each of these points. So I'm going to go left 1, up 0. Left 1. How about right 1, up 0? Now I'm going to go right 3. So 1, 2, 3, up 4. And now I'm going to go right 9. 9, up 8. And I have my logarithmic function. So now if I talk about the domain is now restricted at, starts at negative 2 to infinity. My range is negative infinity to infinity. It's increasing from negative 2 to infinity, which means it's not decreasing. Remember when I have logarithmic functions, when I'm talking about end behavior, x cannot approach negative infinity. Instead, x has to approach this asymptote right there. So as x is approaching negative 2 from the right, because it's on the right side, f of x is approaching negative infinity because it's going down. And when x is approaching positive infinity, f of x is approaching positive infinity as well. So let's now go do number 6. I'm going to go right 2, down 1. That's my new origin. I now have a vertical asymptote at x equals 2. So now I'm going to make my table using x equals at 5 to the y power. 5 is my base, so that's why it's 5 there. So pick my y values, plug in my x values. Plug in my y values to get my x values. So when I plug in 0, x is 1. When I plug in 1, x is 5, 2, x is 25, and then 1/5 and 1/25. So this 2 tells me it's a vertical stretch by 2, so I'm going to multiply all my y values by 2, so I get negative 4, negative 2, 0, 2, and 4. And then this negative tells me I have to reflect it over the x-axis. So if I plot 1, 0, 1, 0 is right here. It's on the x-axis, so I don't have to reflect it. If I plot 5, 2, I'd go right 5, up 2, but instead of going up 2, I'm going to go down 2. And I can't plot 25, so I can plot 1/5, and instead of going down 1, I can go up 1. And now I have my logarithmic function. Whoops. So my domain is 2 to infinity. My range is -infinity to infinity. It's not increasing, which means it's decreasing from 2 to infinity. My end behavior, x cannot approach -infinity, instead x is approaching 2. So that means y is approaching positive infinity because it's going up. And when x is approaching positive infinity, f of x is approaching -infinity. So these next problems, we're just going to go ahead and we're going to evaluate. So all I want to be able to do is turn these into having common bases. So if I look at log 4 of 1 over 256, I want to change this to say log 4 of 4 to some power. 4 to what power gets me 1 over 256? So since I know it's a fraction, it has to be negative. And 4 to what power gets me 256? Well, that's 4. So now that I have log 4 of 4, I'm left with -4 as my answer. If I look at this one, I have log base 10 of 10 and 10 to the 1/2, which means I have log base 10 of 10 to the 3/2, because 1 plus a half is 3/2. So now my log base 10 of 10 cancels out, so I'm left with 3/2. If I look at this next one, log of 1/2 is 1/2 to what power gets me 8? -3. So I'm left with -3. So now I have log 27 of 81. So 27 and no power gets me 1. So let's see if I can turn this into exponential function. This would be 27 to the x power equals 81. So I know 3 to the 3rd power is 27, and then I have an extra x. And 3 to the 4th power is 81. So if I now multiply both sides by logs to get rid of those 3's, I'm left with 3x equals 4. So I'm left with 4/3. If I look at number 11, log 5 base 5 of 5 cancels out. I'm left with 7. ln of e, they're inverses of each other. I'm left with 9. Log of 12 to the log of 12. Those cancel out. I'm left with 15. Log 6 to the 2/16 to the 4/6. Okay, so I have to change 216 to a base of 6. That's 6 cubed. And then I have 4x left over. So those cancel out. So I'm left with 3 and 4x, which makes 12x. So 15, I got to distribute that cubed in. So 2 cubed is 8. And then I have e to the 6th power over 16e to the 5th power. 8 over 16 simplifies to 1/2. And my e's, bigger e is on the top. And I'm done. I really don't need that 1 there either. So if I look at the next one, I have to distribute that squared. So 3 squared is 9e squared times e to the -7. So now I have 9e to the -5th, which is just 9 over e to the 5th. If I look at this next one, 16 log 2 of 5x. So 16, if I want to get a common base, that's 2 to the 4th log 2 5x. So this 4 coefficient should become an exponent. So this should be 2 log 2 5x to the 4th power. So now those can cancel out. So now I'm left with 5x to the 4th power, which is 625x to the 4th. Look at number 18. It says change to base e, which just means I want to change base formula with ln. So remember, it's just ln of the big number over ln of your base. And I know this is a non-calculator question, but if you did type this in your calculator, you typed log 521 in your calculator, and then you typed in ln 21 divided by ln of 5, you will get the exact same answer. So next question, it says expand the logarithm. So I'm going to go ahead and actually distribute this exponent inside. Maybe makes life a little easier. So I have log 9, 2 to the 5th power is 32. And then I have x to the 10th, y to the 5th, z to the 5th. So now I have log 9 of 32 plus log 9x to the 10th power plus log base 9y to the 5th power plus log 9z to the 5th power. So now I have log 9 of 32 plus 10 log 9 of x plus 5 log 9 of y plus 5 log 9 of z. And I'm done. If I go over and I do number 20. So I'm going to go ahead and deal with the division sign first. So I have log base 6 of x plus 3 squared minus log base 6 of 3y squared cubed, excuse me. So this first piece, I can take my exponent and make it a coefficient. But then I can't split up x plus 3 anymore, so that's done. So now it's minus all of this. Log 6, 3 plus log 6y cubed. So now I can make that a coefficient, and I'm going to distribute that negative. So I have 2 log 6 x plus 3 minus log 6 of 3 minus 3 log 6 of y. And I'm done. So now if I look at 21, I have ln of 4x minus ln of, I'm going to go ahead and make this rational exponent, so that's going to be y to the 2/3 power. So this is ln of 4 plus ln of x minus 2/3 ln of y. And there's nothing else I can do. So now if I go and try number 22, I have to condense all of this. So this will be 2 to the 4th, this will be x squared, that'll be 2, and that'll be x to the 6th. So 2 to the 4th divided by x squared, because it's minus, divided by 2, because it's minus, multiplied by x to the 6th. And then I have log base 4 in the front. So now if I clean this stuff up, I have log base 4 of 16 x to the 6th over 2x squared, which is now log base 4 of 8x to the 4th. And I'm done. If I look at number 23, this 3 becomes 3x cubed, this 2 becomes 5 squared, this 5 becomes y to the 5th. So I have log base 2 of 5 times x cubed divided by 5 squared multiplied by y to the 5th. So now I have log base 2 of 5x cubed y to the 5th over 25. So now I can simplify my coefficients. So now I have log base 2 of x cubed y to the 5th over 5. If I look at 24, I'm going to clean up everything inside first and then deal with that half. So that's going to be x to the 4th, and that's going to be x minus 1 squared. So I have ln, I I have ln of 3 times x to the 4th divided by x minus 1 squared. This half becomes a giant exponent, which is 1/2. So now if I go through and I distribute it, I have ln 3 to the 1/2 x to the 2nd power over x minus 1 to the 1st power, which is just x minus 1. And I'm done. If I look at 25, this 2 becomes a squared, this 3 becomes a cubed. So I have ln of x minus 3 squared divided by 6 divided by x plus 2 cubed. And there's nothing I can do, so I'm done. So now we're going to go ahead and talk about finding the inverse of the following. So we didn't like to specifically discuss this, but it's been taught, so I wasn't really concerned of you not understanding what to do. So when you want to find the inverse of something, all you do is switch x and y. So I'm going to put x where y is and y where x is. So now I got to solve for y. So to break log up from y, I got to raise it to the 2nd power. So this is 2 to the x equals y minus 3. So now I'm going to add 3, so y equals 2 to the x plus 3. If I look at the next one, I'm going to replace y with x and x with y. So to get y by itself, I'm going to first subtract 5. So now to get rid of an exponential function, I have to multiply both sides by a log function with the same base, which is 3. So now I have log base 3 of x minus 5. And then when I multiply log base 3 of 3, they cancel out, so I'm left with y plus 1. So now I'm just going to subtract 1. So I have log base 3 of x minus 5 minus 1 equals y. So now, if we go through, now I want to solve these problems. So I see this 2, and I'm going to instantly make it an exponent. So I have log 3 of 4x plus 9 equals log 3 of 2x plus 5 squared. So because my bases are the same, if I take 3 and I raise them, they're going to cancel out. So I'm left with 4x plus 9 equals 2x plus 5 squared. So now that side I have to FOIL. So I have 4x squared plus 10x plus 10x plus 25. And that's 4x plus 9. So now I'm going to have 4x squared, and then I have 20x minus 4x, which is 16x. And then I have 25 minus 9, which is plus 16. So if you take out a 4, so now I'm left with x plus 2 and x plus 2. So x equals negative 2. And you see a negative number with logs and you instantly think it's an extraneous solution, but go back and plug it in. 2 times negative 2 is negative 4. Negative 4 plus 5 is 1, so that still works because my log is still positive. If I plug it into that one, 4 times negative 2 is negative 8. Negative 8 plus 9 is also 1, so it's not an extraneous solution. It does work. If I go and I look at number 29, I want to make common bases. So I have 4 to the 2x minus 3 equals 4 to the 3rd power makes 64. So now when I multiply both sides by log base 4, your bases cancel out, so I'm left with 2x minus 3 equals 3. So now I have 2x equals 6, so x equals 3. If I look at this next one, again, I want common bases, so that would be 4 to the negative 1st power, that gets me 1 over 4, and then that's negative x plus 3. And then this is 4 to the 3rd power, which makes 64, and then I have 2x plus 1. Since my bases are the same, when I multiply by log base 4 on both sides, they're going to cancel out. So I'll be left with -1 times -x plus 3. And I'll be left with, on the right side, 3 times 2x plus 1. So now if I distribute, I have x minus 3 equals 6x plus 3. So now I have 5x equals -6. So x is -6/5. Go over and look at 31. I have to combine my logs on the left side. So when there's addition, it means multiplication. So that's log base 10 of 5x to x minus 1 equals 2. So to get rid of a log base 10, I'm going to take 10 and I'm going to raise it to everything. So now I'm left with 5x times x minus 1 equals 10 squared, which is 100. So now I have 5x squared minus 5x minus 100 equals 0, because I moved 100 to the other side. If I take out a 5, I'm left with x squared minus x minus 20 equals 0. So now I'm left with -5 and +4 equals 0. So x equals 5 and x equals -4. Since this is a logarithmic function, x cannot be negative, so x equals 5. If I look at 32, it's a log function, so I'm going to take 2 and I'm going to raise it. So these cancel out. I'm left with 3x minus 7 equals 2 to the 5th, which is 32. So now I have 3x equals 39, so x equals 13. I hope you all have been very easily able to focus while my dog has been running around like a maniac throughout this whole video. Let's now go to number 33. 33, there's addition, so I'm going to multiply. So I have log base 4 of x times x plus 12 equals 3. I'm now going to raise both sides with a base of 4. These cancel out. I'm left with x squared plus 12x, distributing. 4 cubed is 64. So, 12x. X squared plus 12x minus 64 equals 0. So now I need factors of 64 that make 12. 16 and 4. So positive 16 and -4. So x is -16 and x is 4. It's a logarithmic function. X cannot be negative, so x is 4. Last page. Last page I'm allowed to use a calculator on. So using a calculator, evaluate the following. Hopefully you all don't have any issues with this. I can't really show you how to do this with my calculator, but I can walk you through the steps of what you'd push. You would turn your calculator on. You then press alpha, and then you press the window button, which is all the way at the top. And number 5 says log base. You can also press another button. Yep, if you press math and you scroll all the way down, letter A is also log base. And then I would just type in 7 for my base and 42. And I get 1.9208. And then 35 and 36, I'm just going to tell you what the answers are. If you have dying issues with this, make sure you come and talk to me. It said round to 4 decimal points, so I did. All right, let's look at these next ones. Solve the following. 8 to the x equals 20. So notice that 8 and 20 can't be changed to common bases. So I'm just going to multiply by any log, and I'm just going to do the log with not the most common log, which is base 10. So now I have x log of 8, because I brought that exponent down in front, equals log of 20. So to get x by itself, I'm going to divide by log of 8, which is why now I have to use my calculator, because I have log of 20 divided by log of 8, which is 1.4406. If I go across to 38, log base 3 of x equals log base 9 of 6x. So on this problem, my bases of my logs aren't the same. So this is where I have to use the change base formula. So you always change the log with the bigger base. So you're going to keep the log with the smaller base the same. And you're going to change the log of the bigger base to be log 3, base 3, top and bottom. This number goes on the top. Your original base is now the denominator. So now I have log base 3 of x equals log base 3 of 6x over log base 3 of 9. 3 to what power is 9? That's 2. Multiply both sides by 2. I have 2 log base 3 of x equals log base 3 of 6x. So if I take that 2 and I erase it and I make it an exponent, my logs can now be raised to the third power, or it can be raised to a power. It can be the power, and your base can be 3. So now I'm left with x squared equals 6x. So now I have x squared minus 6x equals 0. Factor out an x. X equals 0 or x equals 6. Logs, x cannot be 0, has to be greater than 0, so x is 6. If I look at number 39, same type of problem as 37. I can't change 4 and 6 to have common bases, so I'm going to multiply by a common log. You can multiply with a common log, you can multiply by the natural log. It really doesn't matter as long as your base is the same. So I'm going to have log base 10 of 4 to the x minus 2. So x minus 2 is just going to become a coefficient. And now I have log of 4 in the front. And I'm going to multiply by log on the other side, and 3 minus x is going to come down, and I'm left with log of 6. So now I'm going to distribute. I have x log of 4 minus 2 log of 4 equals 3 log of 6 minus x log of 6. So now I'm going to move all my x's to one side. So I have x log of 4 plus x log 6 equals 3 log 6 plus 2 log 4. So now on the left I'm going to factor out an x. So I'm left with log 4 plus log 6 equals 3 log 6 plus 2 log 4. And now I'm going to get x by itself by dividing by log 4 plus log 6. And now I'm going to take all of this and I'm going to type that into my calculator. You either have to be very careful when you're doing that, or you have to do the alpha y equals enter to get the pretty fraction, or you have to use a lot of parentheses. So be very, 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 very careful with how you're typing this in. But when you type it in, you should get 2.5638. If I go over and look at number 40, ln, so I got to subtract 3 on both sides. So I have 4 ln of negative x equals 18. I'm now going to divide by 4. ln of negative x equals 4.5. To get rid of ln, I have to take it to the e. So that'll cancel out, and with negative x equals e to the 4.5, which is 90.0171. So x is just the opposite of that, negative 90.0171. So now we come down to talk about our formulas. You have to have all these formulas memorized. So what's the formula for calculating compound interest? That's P equals A to the 1 plus R over N to the NT power. If I can write today, that'd be beneficial. Not wanting me to write over there. Okay. Formula for calculating interest continually. That's P equals A e to the RT. Exponential decay, that's P equals A to the 1 minus R to the T power. And exponential growth is P equals A to the 1 plus R to the T power. So let's look at the first problem. It says, when receiving $7,500, I am receiving $7,500 as a tax refund and wish to deposit into the bank with an interest rate of 1.6%. How much will the account be after 18 months if the account is compounded monthly? So it's compounded monthly, so I'm using this formula. So P equals A 1 plus R over N to the NT power. So P equals A, that's 7,500. 1 plus my interest rate is 0.016. Divided by N is how many times? Monthly is 12 times. N is 12. T is time in years. Notice it says 18 months. To figure out time in years, I have to do 18 divided by 12, and that's 1.5 years. 18 months is 1.5 years. So now I type all that into my calculator, and I get $7,682.05. So the next one says, what if it was compounded quarterly? So again, P equals A is still 7,500. 1 plus my percent interest rate is the same, 0.16. Quarterly is 4 times a year, so now that's 4 times 1.5. Type all that into my calculator. I get $7,681.81. If I look at the last one, when it's compounded continuously, that means I'm using that formula. So P equals 7,500 e to the R 0.016 times 1.5. So that means P equals $7,682.18. Let's now look at 42. 42. I bought a new car for $18,000. If the rate of depreciation is 12% yearly, how much will the car be after 4 years? So since the rate of depreciation, that just means I'm using the exponential decay model. So I would do P equals A, which is 18,000, times 1 minus my percent is 0.12, and I raise it to the 4th power. When I type that into my calculator, my car will be worth $10,794.52. And if I look at the last one, how long will it take for my car to be half of its original cost? So its original cost was $18,000. So what's half of that? Well, that's $9,000. So it's saying, well, how long will it take to be $9,000? So let's plug in everything that I know. The original price was $18,000. It's 1 minus. I want to know how long will it take. So my interest rate is still the same. And now I have T. I'm looking for T. So I'm going to go ahead and divide by 18,000. So I get 0.5 equals 1 minus 0.2 is 0.88 to the T power. So to get a variable out of the power position, I have to multiply both sides by the log of the base, log of 0.88. So this is log 0.88 of 0.5 equals T. So now I type that in my calculator, and T equals 5.4, which means in about 5.5 years, my car will be worth half its value.